For over 2 decades, the International Space Station has been humanity's outpost in low Earth orbit, a microgravity laboratory, an engineering marvel, and a symbol of international cooperation. But even great chapters must eventually end. The ISS is aging. Its systems, some designed in the 1990s, are nearing their limits. And soon, its era will close. But what comes next? In the shadows of this transition, a new vision is rising. One not built by governments alone, but by private innovators. Its name is Axiom Station. This isn't just a replacement for the ISS. It's a reimagination, a new platform for science, manufacturing, medicine, and commerce in orbit. This is how Axiom Station changes space research forever. The Axiom Station is the first commercial space station being developed for low Earth orbit. Designed by Axiom Space, it will be assembled module by module, initially attaching to the existing International Space Station before becoming an independent orbital platform. Its architecture is sleek, modular, and scalable. It will feature advanced research labs, Earth-facing observatories, crew habitats, and even modules designed for manufacturing and medical research, all orbiting 400 kilometers above the Earth's surface. But what truly sets Axiom apart isn't just its hardware. It's how it was conceived. This is a station not bound by legacy systems, but optimized for modern science. Designed with private researchers, national space agencies, and commercial innovators in mind. It isn't just a science platform, it's an orbital economy. And that shift changes everything. Why go to space for research at all? The answer lies in microgravity. In the weightlessness of orbit, matter behaves differently. Fluids flow in strange ways. Cells grow in patterns never seen on Earth. Flames flicker in perfect spheres. Protein crystals form more precisely. Even human physiology changes, offering insights into health, aging, and disease. The International Space Station proved the potential of this environment. But with limited time, space, and resources, research was always selective. Axiom Station promises something different: dedicated, on-demand access for researchers from around the world. University scientists, pharmaceutical companies, materials engineers, biotech startups. They'll have a permanent orbital lab with tools tailored to their missions and fewer constraints on time and resources. From cancer treatments to climate sensors to next-generation semiconductors, the new frontier of science will orbit Earth daily. Some of the most exciting breakthroughs in recent space research have come from unexpected places. In microgravity, human stem cells grow more rapidly and organize more efficiently, potentially accelerating tissue regeneration research. Certain cancer cells behave differently, making it easier to study how tumors grow and respond to treatment. And protein crystals, grown in space, become clearer and more orderly, helping scientists better design pharmaceuticals. Axiom Station will take these findings and expand them. With custom research modules, autonomous experiment racks, and real-time data links to Earth-based labs, scientists can test hypotheses at speed, scale, and depth previously unimaginable. And it's not just about biology. New materials forged in microgravity, metal foams, superconductors, fiber optics, can be purer, lighter, and more advanced. On Earth, gravity pulls and settles. In space, molecules float freely, assembling in ways they never could at sea level. The result? Innovation that could redefine industries. Axiom Station isn't just about space. It's about how space helps Earth. Imagine testing climate sensors in orbit that can scan the Earth's surface with centimeter-level resolution. Imagine refining artificial intelligence algorithms using data collected from space-based telescopes and Earth observation tools. Imagine doctors performing robotic-assisted surgeries remotely, practicing for space, improving care on Earth. The Axiom platform will serve as a testbed not just for science, but for the technologies of tomorrow: robotics, remote medicine, high-speed communications, and advanced manufacturing. And all of this in orbit, accessible, scalable, private. What begins 400 kilometers above Earth will ultimately change lives on Earth. Until recently, space was the exclusive domain of governments. NASA, ESA, Roscosmos, they built the infrastructure. They chose the experiments. They own the stations. But today, the private sector is stepping up. Axiom Space isn't just designing hardware, it's opening access. Its station is designed for customer research, whether national space agencies, pharmaceutical companies, climate scientists, or university teams. And with reusable launch systems from companies like SpaceX and future low-cost crew transport, access to orbit is becoming more frequent and more affordable. This democratization means more experiments, faster development, and diverse global participation. Countries that never had access to space can now conduct orbital science. Startups can test prototypes in zero gravity. Researchers can iterate quickly. Axiom Station is building the infrastructure for a true space economy, where research isn't limited by access, but only by imagination. What will science on Axiom Station actually look like? Picture this: a private research module, fully automated, tuned for a specific biological experiment. Onboard AI monitors the data in real time, adjusting environmental conditions as needed. Researchers on Earth receive live updates and can tweak parameters remotely without needing a human in the lab. In another module, a robotic arm 3D prints advanced materials in zero gravity, testing tensile strength and composition mid-print. Elsewhere, a rotating experiment drum simulates partial gravity environments, like Mars or the Moon, helping scientists test plant growth or soil chemistry for future colonization. Every module is modular, interchangeable, upgradable. The station is not a static lab. It's a living research platform that evolves with science. Axiom Station isn't just about Earth orbit. It's a stepping stone. The technologies tested here, autonomous life support, orbital manufacturing, artificial gravity, long-duration health monitoring, will be essential for missions beyond Earth. Mars, the Moon, asteroid mining, deep space telescopes, interplanetary medicine. Research conducted on Axiom can lay the groundwork for how we live and work in space permanently. It's the first floor of a much taller structure, a future where humans expand beyond Earth and science follows us into the stars. And unlike past space programs, this time the infrastructure is commercial, designed to scale, designed to adapt, and designed to go farther. Science on Axiom Station won't just be American. It won't just be corporate. It will be global. Axiom is working with nations around the world, developing astronaut training programs, research partnerships, and long-term microgravity projects. For developing countries, this is a historic opportunity to enter space science without launching their own infrastructure. For students, it's a way to see their experiments fly in orbit. For the public, it's a reminder: space is not just for the few anymore. And through commercial astronaut missions, even the path to orbit is changing. Scientists, doctors, educators, people who never imagined they'd fly in space, may soon conduct their work aboard Axiom. Research in space is becoming human-centered, inclusive, and boundary-breaking. The International Space Station taught us what's possible. Axiom Station will show us what's next. A future where science doesn't wait years for a launch window, but runs continuously in orbit. A future where materials are tested, medicines are discovered, and ecosystems are grown, not in theory, but in space. A future where the edge of Earth's atmosphere becomes the world's highest lab bench. This is not just a new space station. This is the transformation of space from destination to platform. Axiom Station changes space research not by replacing what came before, but by building what comes next.